Welcome to the deep dive. In today's world, information just comes at us constantly. It's really easy to feel swamped, but you still want to actually understand complex stuff, right? Without getting lost in all the noise. If you're looking for a way to get truly informed, well, you're in the right place. Today, we're diving deep into something that, okay, it might sound a bit technical initially, automation testing. But honestly, this is fundamental to making software work better, faster. It impacts pretty much every app or website you use daily.
It really does. It's fascinating how something working behind the scenes is just so critical for the quality, the reliability of everything we depend on online.
Absolutely. It really underscores why this backstage work matters so much. And our source material today is really interesting. It's a collection of over 50 interview questions and, crucially, the expert answers about automation testing. Think of it like getting an insider's view,
Yeah.
the core ideas, the common hurdles, the practical stuff professionals deal with.
Yeah, it's like a curated tour, really. Cuts right to the chase on what you actually need to know to understand this space.
Exactly. So our mission today is to pull out those key nuggets of wisdom, give you a clear, hopefully engaging overview of automation testing. We want those practical takeaways, the aha moments. So let's get into it. First things first. What is automation testing?
Okay, so at its heart, automation testing means using special tools to run test cases automatically. But the key thing here, and this trips people up sometimes, its main goal is to reduce manual tests, not get rid of them completely. It's about being smart with your effort.
That's a really important point. So it's not a replacement, it's more like a strategic boost, which, leads to that bigger question, when do you automate? And maybe more importantly, when don't you?
Right, and that often comes down to ROI, return on investment. Automation really shines for repetitive tasks. Think regression testing, running the same checks again and again to make sure new code didn't break old stuff. It's also great for what we call smoke and sanity tests, quick checks to see if the basic application is even working. Or testing with loads of different data sets. Basically, the more you run an automated test, the more value you get back.
So if you run it tons of times, automate. Run it once, maybe not. But
Yeah.
how do you actually measure that ROI? Is it just about saving time? Or are there other costs, like manual testers getting tired and missing things?
That's a great question. Time saved is huge, yeah. But ROI also includes fewer human errors, getting feedback to developers faster, and ultimately higher quality software. The hidden costs of not automating, oh yeah, tedium, higher error rates from doing the same thing over and over. That definitely leads to missed bugs, slower releases. It impacts competitiveness. And that brings us to when not to automate. You generally want to avoid it if the application changes constantly. You'll just be rewriting scripts all the time. Also not great for one-off tests or random ad hoc testing. And definitely not for exploratory testing. That needs human intuition, the what happens if I do this kind of thing. Machines aren't good at that.
Right, like the feel of an app, how intuitive it is. That needs a person. You can't automate subjectivity.
Exactly. Plus, tests needing complex setup each time, or ones with really unpredictable results, probably better to keep those manual. Now, comparing them more broadly, manual testing, it's usually slower. And yeah, prone to human error, especially on big projects, it's tedious. Manual testing typically follows the STLC, the software testing lifecycle, that whole structured process.
Okay, and how does automation measure up on those points?
Well, automation is way faster and much more reliable once your scripts are solid. It does cost more upfront tools, set up time, but pays off long-term and save time and effort. So overall costs can actually go down. Automation uses tools, but it still fits within that STLC framework. And generally, automation finds more defects because it's fast and consistent. But it does require testers with, stronger technical skills to build and maintain everything.
It sounds like you're building this reliable machine that can just run tests consistently. Okay, so if you decide automation is the way to go, what's the actual process? What are the main steps?
Well, it usually starts with picking the right tool. That's crucial. Then you define the scope. What exactly are you automating? After that, it's planning, designing, and actually developing the test scripts. Then you execute the tests, run them, and finally there's maintenance. Super important, keeping those tests up to date and useful.
Let's focus on that planning stage for a second. Sounds like getting that right is key. What goes into it? What happens if you mess it up?
Oh, planning is absolutely critical. You have to choose the right automation tool, maybe the right framework too. That choice echoes through the whole project. You also need to clearly define what's in scope and out of scope. Manages expectations. Setting up the test environment properly is part of this. Often you'll map out timelines, maybe using Gantt charts, and you define your deliverables, what reports, what results are you expecting if you rush planning. Big problems. Wrong tool, automating the wrong things, unstable environment. It leads to delays, wasted effort, big headaches later.
Yeah. Sounds like paying attention up front saves a lot of pain. Okay, let's talk building blocks. Test scripts. What exactly is a test script?
Basically, a test script is just code. It's a set of instructions that tells the tool what to do on the application. Its whole job is to check if the application works as expected based on the requirements. And when it runs, it tells you pass or fail. Simple as that, fundamentally.
But making that script good, readable, maintainable, that's the trick, right? Yeah. What are some rules for writing effective automation code?
Absolutely. That's where the real skill comes in. Good practices are vital. Always add comments. Explain your code. It's like leaving notes for your future self, or for the next person who has to fix it. Find bits of code you use, often reusable methods, and put them in one place. Make them easy to call. Stick to coding conventions for whatever language you're using. Consistency helps everyone, and this is a big one. Keep test data separate. Things like URLs, logins, passwords they change, don't bury them in the script. Put them in a separate file. Makes updates way easier. Also, run your scripts often, use clear naming, indent your code properly, handle errors gracefully, and yeah, use frameworks.
Frameworks. You mentioned them. They sound important for structure and maintenance, or are they like required?
Yeah.
Or just a really good idea?
They're not strictly mandatory, no, but they are a very good idea. They provide guidelines, a structure that makes managing and maintaining your test scripts so much easier. Definitely a strategic advantage. There are a few main types. Modular, which is about breaking things down and reusing parts. Data-driven, where your test data lives outside the script, so you can run the same steps with lots of different inputs easily. Then there's keyword-driven and hybrid, which, as the name suggests, often mixes ideas from the others to get the best of different approaches.
That's quite a few options. Is there one type that's generally best for, say, a growing project? Or does it always depend on the specifics?
It really does depend on the project, the team, the application itself, but hybrid frameworks often offer the most flexibility. They let you combine things, like the reuse from modular with the data separation from data-driven. Makes them pretty adaptable. What makes any framework good, though? It needs to be modular, easy to change parts, reusable common functions easily available, consistent. The tests should be independent, not relying on each other to run, and it should integrate well with other tools you might be using. It becomes the backbone.
And what are the key parts, the essential modules inside a good framework?
You definitely need test assertion tools, think JUnit or TestBD. They're what actually check if the result is what you expected and mark the test as pass or fail. You need something for data setup, managing that external test data. Build management tools, help package and deploy your tests. Continuous integration or CI tools are vital these days for automatically running tests when code changes. Reporting tools, obviously, to see the results clearly. And logging tools, super important for figuring out what went wrong when a test fails. Helps debugging.
With all this code flying around, changing all the time, version control must be essential, right? Using tools like GitHub.
Oh, absolutely non-negotiable. Version control like Git, often hosted on platforms like GitHub or GitLab, is vital. It tracks every change, lets you see who changed what, makes it easy to go back if something breaks. It's your safety net and how teams collaborate on code effectively. And tied into that is documentation. It's crucial for making automation repeatable and understandable. You need to document your methods, the overall process, test designs, any significant code changes, the test cases themselves, the automation plan, bug reports. It ensures longevity and clarity.
Right, it's all about making the whole effort sustainable and transparent. Okay, let's switch gears to the tools themselves. So many choices. How do you even start picking the right one?
Yeah, choosing a tool is a big decision. You need to look at several things. Does it support the environments your application runs in? Web, mobile, desktop. Is it easy for your team to learn and use? Does it have good debugging features? How well does it identify objects on the screen? That's fundamental. Features like record and playback can be helpful, especially early on. Does it support the programming languages your team knows, like Java or Python? Can it handle things like image testing or database checks? Does it support parameterization running tests with different data? Does it work well with the frameworks you want to use? Is there good documentation, community support available? And of course, cost is always a factor. Plus, you need a good reporting system. Lots to weigh up.
Definitely. So what are some of the big names, the popular tools people should be aware of, and how do they fit in different categories?
Well, some of the really common ones are Selenium, Micro Focus UFT, that used to be called QTP, and maybe Rational Robot, though it's a bit older. Broadly, you can categorize them. You've got open source tools, like Selenium. They're free, the code is available. Then there are vendor tools like Micro Focus UFT. You buy a license, you usually get commercial support. And finally, some companies build their own in-house tools tailored exactly to their specific needs.
Let's dig into Selenium first. It feels like everyone's heard of Selenium. What's its deal?
Selenium is huge, yeah. It's free, open source, mostly for automating web browsers, though it has mobile capabilities too. It's actually a suite of tools. There's Selenium IDE for simple record playback, Selenium WebDriver is the main engine for programming browser actions, and Selenium Grid lets you run tests across many machines at once. Big advantage. It supports lots of languages. Java, C#, Python, Ruby, JavaScript. People use it for all sorts of web testing, functional, regression, even some basic performance checks. And yeah, it can easily grab info from the browser, like getting the current URL to check you're on the right page.
Okay, what about Micro Focus UFT, the old QTP? How's that different?
Right, UFT is a commercial tool. Its big strength is its massive environment support. It goes way beyond just web. Think SAP, desktop apps, Java applications, mobile, mainframes. It handles a lot of complex enterprise stuff. That's where it really shines. It mainly uses VBScript for scripting, and it integrates tightly with other microfocus tools like ALM for test management and LoadRunner for performance testing. It has features like business process testing, a built-in keyword framework, good XML handling, and really robust ways to check application states called checkpoints.
Sounds very enterprise-focused. Now,
Yeah.
you mentioned SikuliX earlier with its visual image match. That sounds different. When would you use that?
Exactly. SekuliX is pretty unique. It works by looking at the screen visually. You give it little screenshots, images of buttons or fields, and it finds them on the screen and interacts with them. This means it can automate almost anything you can see, even if there's no easy way to access the underlying code, like with some older desktop apps or things built with Flash. It has a relatively simple API, can even work alongside Selenium sometimes. And yeah, that Flash object support is a big deal because Selenium just can't do that. So if you're stuck with some weird custom control or a legacy system, SikuliX might be the answer, using that visual approach where normal locators fail. It doesn't care about the tech underneath, just what's displayed.
It's a really clear distinction, visual matching for tricky situations. What about some of the other popular tools? Cucumber, Test Complete, Cypress. They seem hot right now.
They definitely are gaining traction. Cucumber is open source, focused on behavior-driven development, BDD. It lets you write test specifications in plain English, or something close to it, using a format called Gherkin. This makes tests understandable even for non-technical people. Great for web apps, supports various languages. Test Complete is more of a broad UI testing tool, desktop, web, mobile. It's well known for its cross-browser testing. Record once, run on Chrome, Firefox, Edge, etc. Pretty neat. And Cypress is another open source framework, this one built with JavaScript. It's become really popular, especially with front-end developers, because it's generally seen as faster and simpler for modern web testing needs. Lots of built-in features.
And you mentioned cross-browser testing with Test Complete. That seems incredibly important today, right? Everyone uses different browsers.
Oh, absolutely critical. Cross-browser testing is basically making sure your website or web app works correctly and looks right on all the major browsers, Chrome, Firefox, Edge, Safari, and maybe different versions, and on different operating systems too. It's all about ensuring that consistent user experience no matter how someone accesses your site.
Okay, let's shift to some practical stuff, the nuances you hit in the real world. This is where theory meets reality. First big question, is 100% automation actually possible, or is it just a myth?
Yeah, that's a common one. And no, generally 100% automation isn't feasible or even desirable. It's mostly a myth. There are things like CHAs designed specifically to stop bots. You can't automate those easily or reliably. Or think about test cases you only run once in a blue moon. The effort to automate them just isn't worth it. No positive ROI. I remember seeing a team try to automate everything. They spent more time fixing those rarely used automated tests than just running them manually when needed. Classic over-automation.
So smart automation, not total automation. Got it. What's a realistic number of test cases someone can automate in a day, like an average?
It really varies wildly with complexity, but as a rough guide, maybe 2 to 4 simpler test scenarios per day. If the scenarios are really complex, involving lots of steps or tricky validation, that might drop to just 1 or 2 per day. It's not about quantity alone.
Makes sense. And if you have a big suite of automated tests, how can you make it run faster? Sometimes they can take hours, right?
They sure can, especially with lots of UI interaction. One way is just writing more efficient scripts, obviously, but bigger strategies involve running tests in parallel, using tools like Selenium Grid to distribute the tests across multiple machines or cloud services. That can cut down time dramatically. Another technique is using headless browsers. These run without rendering the visual UI, which is often faster. And sometimes you can speed things up by interacting directly with application APIs for setup or certain checks instead of clicking through the UI for every single step.
Is automation testing generally considered black box or white box?
Primarily, it's black box testing. You're testing the application from the outside based on inputs and outputs requirements without needing to know the internal code structure.
Okay, let's get specific. How would a tool like Selenium handle something like an alert pop-up box on a web page?
Selenium WebDriver has specific commands for that. Your script would first need to switch focus from the main browser window to the alert box itself. Once focused, you can use commands like accept to click OK or dismiss to click cancel. After dealing with the alert, you then switch the focus back to the main window to continue with the rest of the test steps.
That's a good concrete example. So if you were automating something super common like a website login, what would the steps look like?
Okay, for a login. First, you really need to understand the requirements, what constitutes a valid login, what are the expected error messages, etc. Then, identify all the scenarios. Successful login, login with wrong password, login with wrong username, maybe blank fields, positive and negative cases. You'd probably prepare a data file with usernames and passwords for these scenarios. Then, you launch your tool, write the script to navigate to the login page, find the username field, the password field, the submit button, identify those elements. The script then enters the data from your file, clicks login, and crucially verifies the outcome. Does it see the welcome message for success? Does it see the correct error message for a failure? That verification is key.
Sounds very methodical, even for something seemingly simple. What about using automation and agile development? Does it fit well? Are there challenges?
It fits well in some ways, but yeah, there are challenges. Agile means requirements or user stories can change frequently. If stories are changing constantly, your automation scripts might need constant updates, which can be time-consuming and costly. That's a friction point. Also, if a project needs very detailed, formal documentation for every test, automation might not align perfectly with Agile's focus on working software over comprehensive documentation. However, automation is absolutely fantastic for regression testing in Agile. With rapid iterations and continuous integration of CI, you need quick feedback. Running automated regression tests frequently ensures new changes haven't broken existing stuff. It's almost essential for CI/CD pipelines.
So it shines for those stable, repeatable checks within the fast agile cycle, even if it's tricky for brand new, shifting features. Wow, this has been incredibly thorough. We've really gone from the basics, what automation testing is, through the processes, the importance of planning, to building scripts, using frameworks, choosing tools like Selenium, UFT, SikuliX, Cypress, comparing them. And we've hit those practical points too, like 100% automation being a myth, handling alerts, and how it fits into Agile.
Yeah, it's a big field and definitely dynamic. It's constantly adapting to how software gets built, and it really does underpin the quality of so much of the tech we interact with every day.
Absolutely. Which kind of leads us to a final thought for you, the listener, to chew on. Thinking about how fast technology changes. How might our definition of a good automation tool or framework evolve over the next few years? What skills might automate experts need beyond just knowing how to code or use a specific tool? Maybe more AI understanding, better strategic thinking. It's worth considering how this field's evolution might impact your own digital life or maybe even your career path.
That's a great point. The landscape is always shifting, so looking ahead is key.
Indeed. We really hope this deep dive has given you a much clearer picture of the world of automation testing. Thanks for joining us. Until next time, keep diving deep.